Alright guys, we're moving to Chapter 8. Chapter 8 is kind of a lightweight chapter. I don't expect that we're going to spend more than a single lecture on it, and it may be a short lecture at that. So we may go back and talk about static members a little bit more. Specifically, we'll probably mention the idea of a static class. Well, let's go ahead and look at the PowerPoint. So, software engineering. Coding style conventions, helper methods, encapsulation, algorithmic design, top-down design, stubs, merging the driver method into the driven class, which I especially recommend you not do, accessing instance variables without using this. So coding style conventions, the book recommends a particular convention. At the top of your class, the top of the class file, begin with this specific style of comment block. Okay, yeah, that's all well and good. You know, maybe I should demand it. I don't really. I particularly think that each method should come with a description, and they're not demonstrating that. It's not a bad idea at all to go ahead and add some comments as to what your variables are. And you see me add this all the time, right? The add class student driver and then the end of main. I do follow those pretty religiously. I would appreciate it if you did the same. So inside your class, you could mark off, various sections with a line of asterisks. You could describe your constructor, what it does. They're not showing using Java docs to describe these things, which is kind of the default that NetBeans will adhere to. You can use NetBeans to create Java doc style comments. Once you generate your Java doc style comments, you could even create some documentation in the form of HTML pages using NetBeans that would draw that information from Java doc. And let's see if there's any interesting comments down here at the bottom that we're supposed to be looking at. I'm not seeing them. So what are these guys meant to indicate? Good question. There's no notes down at the bottom telling us. Is that a correct statement? That is a correct statement. All right. So they're showing that if you have a multi-line statement, then you just tab over the underneath lines, right? The second, the third, and the fourth lines, and so on. The book recommends, and I quite agree, to use in a block style brace placement. Alrighty, helper methods. Reasonable topic. As with all examples discussed so far, methods usually use public, and then the public methods are considered to be part of the class's interface. So what is a class? It's a collection of data and the methods that manipulate it. So you make your methods public so that the client code can access those methods and manipulate the data. However, sometimes you have methods that only the class itself should use. So they do not need to be part of the public interface, in which case you could call them helper methods, and you could give them private access to ensure that they are only called from within the class. So maybe they're a little bit too specialized in their function to allow a programmer writing some client code to access, right? Maybe your class needs to be able to open a file, write to a file, do some stuff with it, and close the file. And maybe you want your class to handle that entirely, and maybe you don't want the driver class to even have, access to the specific functions that do that. So you can make the functions that create the file, and write to the file and close the file private. You can make those private methods, and then the primary methods, the public methods in your class, could access those private methods, those helper methods, in order to perform those tasks. But it could conceivably ruin the program if the client code called the close file method before your class was done with the class. So you'd make it private so that it could not do that. So Suppose you're asked to write a program that handles order entries for sports uniform shirts. The program should prompt the user for primary color and trim. For each color, it needs to perform the same input validation. Make sure that the color is one of the specific colors allowed. The input validation code is non-trivial. It's in charge of prompting the user for a color entry, checking whether the entry is valid, and repeating the prompt if the entry is invalid, and then convert the color into a full word color value. And so, that's a loop, and it's a loop that's going to, a considerable amount of trouble to get the input, validate it, and convert it. So it makes total sense to encapsulate that into a method. It does not make total sense for the client code to be able to call the code that would pop this up, right? The class is the only thing that should be popping this method up. Popping this information up. Client code doesn't need to be able to trigger another color menu. So, the example shows creating a method called select color, and you pass in, an argument that specifies the kind of color that you're passing, that you want to collect. So we might want to pass in something that was described as primary, and then another thing that was categorized as trim. And so now we need to find those methods, those helper methods. So select color, and then a description of what kind of color this is, right? So the select color can create its own scanner. Nothing wrong with your project creating several scanners. And then it does a loop, a do-while loop, printing out the colors, asking them for the color, continuing to repeat while the color does not equal W and the color does not equal R and the color does not equal Y. And then based on that letter that they choose, we will convert the color to the appropriate word, white, red, or yellow, and then we will return that word. And so anytime the code needs for the user to select from one of the letter codes and convert it to one of the appropriate colors, it calls that method. And again, it does not make sense for the client code to have access to this method. So it is declared as private. It's a helper method that helps the class do something, but the client code, the driver code, another programmer using your code does not need to suddenly call select color. So benefits of using helper methods. Using helper methods can reduce code redundancy. Yeah, sure enough, we don't have to write that loop, that data entry loop and validation multiple times, but that's just a normal reason to write a method. By moving some of the details from great big public methods, you enable the public methods to be streamlined, to be smaller, which leads to improved code readability. Yeah, that's just another reason to use methods in general. So far they haven't argued why it should be made private. And the reason why is encapsulation. The class should only expose the methods, make public the methods that the driver code really has need to get a hold of. The same reason that we make the data private. The client code shouldn't be able to touch the data methods, the data variables, the instance variables, if changing those would violate the concept of the class. If we need some kind of validation to changing the data, then you would want your mutator to be able to monitor and to validate it, right? And so you would not expose that variable as public. You would make it private, as we've discussed, and you provide the getters and the setters. And so far, our getters and setters have been, almost trivial. Just passing in a variable, and then setting this dot variable equal to that parameter, or returning this dot variable. But that setter, that mutator, could be considerably more complex. It could be similar to that function, that method that we just saw, right? That it does some data validation, and it rejects the effort to set it if the data is not correctly set, So if we're setting a student ID and it's not 6 digits long like student IDs are supposed to be, then we could return false, or even worse, even more drastically return an exception. so that the calling code, flat out knows that something went seriously wrong and it was not able to set that. Or, if you're setting the amount of a deposit, you might not allow somebody to deposit $0 or a negative amount, that kind of thing. So a program exhibits encapsulation if its data is hidden. Since other classes aren't able to directly access the encapsulated data, it's more difficult for the classes to mess things up. So you break a big problem into separate classes where each class holds a set of encapsulated data, which are marked private. And then the class's tasks are broken into methods, where those methods are attached to the class that contains that data. This took me back a little bit. I had to stare at it again. Separate methods where each method holds a set of encapsulated data. That's a weird way to think of it. But yeah, a method can carry its own variables around, just your local variables, right? If you're going to calculate the area of a circle, then your thing may need to calculate, the diameter of the circle first, and so that could be a local variable. The temporary variables that your code needs in order to perform the calculation before that result is returned or stored into one of the instance variables. You just make those local, meaning that they're inside the method, right? They're inside the braces of the method. And this author is claiming that that's encapsulated as well. I consider the encapsulated data to be the instance members, right? A local variable is just a local variable, regardless of whether it was in a class or not. But I guess you could say that it was encapsulated because it's not available to another class. But that's just the entire idea of local variables that's introduced, like in chapter 2 or wherever the idea comes across. And you've used local variables throughout your entire programming education. Okay, so yeah, data encapsulated into a method are local variables. Sure, we'll run with that, but I'm not going to ask you that on a quiz. Declaring data as instance variables is one form of encapsulation. Declaring data as local variables within another method is a form of encapsulation, which is the stronger, more hidden form of encapsulation. Well, the instance variable may be shared by all the methods in the class, where local variable is local to one method. So local variable is more encapsulated. And now I'm starting to agree with them on one point. If you have some function that needs to calculate an intermediate value. Now, for example, if you're going to make a circle class and it's going to take care of its radius, right? That's going to be a private variable. And it needs to be able to calculate the circumference, right? And maybe the circumference is, I was about to say measured in radians, but no, you don't measure circumference in radians, and it's not a geometry class. But you know what the circumference is? It's the length of the line that defines a circle, and you know what the area is. So you might write a, why did I make that an int? I don't know. But you might write a get circumference method, get circumference, and it does some stuff. And you might write a get area method, and it does some stuff. Now, a typical student response to this request would be, oh, well, I need to get a circumference. I better make a circumference variable, right? And I need to get an area. Well, I better make the area private variable, instance member. No, you absolutely should not, because these are supposed to be derived from the radius. If the calling code managed to come in and set the circumference, and then later the radius changed, then the circumference now would be stale data. It would no longer be valid, right? So if your client code did set radius, and set the radius to 10, and then it called get, circumference for whatever purposes to print it out, and then it set the radius to something else, well, now the circumference data is no longer correct. And so if there was another method in here that used the circumference for something, then it's using bad data. It's using data that is no longer correct. It was correct when the radius was 10. It's no longer correct when the radius is 20. So you need to decide what data should be calculated every time and what data you should actually store. And you may think of the area as the circle as a fundamental trait of the circle, but it's really not. It's a calculation that's derived from the radius. So this is the only instance member that our class actually needs, and these things should not be part of the class itself. Instead, they should be local variables inside, right? And so then you could calculate your circumference via whatever formula it is, 2 pi r, I think. 2 times math dot pi times this dot radius, and then return the circumference, right? And that way, anytime anything needs a circumference, whether it's a member, a method of this class, or the calling code needs a circumference, then it gets calculated to ensure that it's accurate. So, the circumference has been made super duper double encapsulated by putting it as a local variable inside that method. All right. I guess that's a worthy concept. The idea of not putting instance variables that need to be calculated is an extraordinarily important idea. Strongly recommend that you do that. Similarly, if you have an account that calculates somebody's pay rate, not an account, a class that calculates somebody's pay based on their hours worked and their, whether they're allowed overtime or not and that kind of stuff, you would not want to put that total pay as an instance variable. Even if it was a private instance variable, it's maybe something that needs to be calculated every single time because the person's pay rate and hourly, hours worked that week might change, in which case that variable is containing stale data, no longer accurate data. And so you'd want to provide a method that would calculate it every single time that it needed to be used. Hope that makes sense. And I really hope you didn't type that in. The fact that I typed it in the notepad hopefully dissuaded you from doing that. So how to declare which to use. You declare a variable locally if the variable only needs to persist, stay alive, for the duration of that particular method. So for example, to calculate the area, you may need the radius, but the class may only be tracking the diameter. Well, how do you calculate a radius? It's half the diameter. But that's a temporary variable, right? We made whatever decision for whatever reason that the circle is going to track its diameter. Maybe that's because users think in terms of diameter, not radius, whatever. So in that case, radius is a temporary variable. Only that particular method needs access to it. You would not make it an instance variable, you would make it a local variable. So you declare a variable locally if only one method needs to access it, if the data only needs to stay alive for the duration of that particular method. It's the same idea as in C++, not making something a global variable unless it absolutely needs to be. And global variables are kind of a bad idea in C++ anyways because you can't control which functions are going to modify it. Well, I mean, you can, you wrote the program, but you make it conceptually confusing. Same thing here, you don't need to make things instance variables if they don't need to be instance variables, if they're not actually part of the data that the class needs to be maintaining. If it's just a temporary variable, part of a calculation. For example, in the code that we just saw up here where the user entered a letter to represent a color, we don't need to store that letter anywhere, right? It was just a temporary piece of data used to calculate the word, right? Red, white, or yellow. So we didn't need to store that letter anywhere. It's just a temporary variable declared in the method that, got that information. And so you declare a variable as an instance variable if it stores a fundamental attribute or if it needs to persist for the duration of the class's objects. If it needs to persist longer than the duration of one particular method's execution. Algorithmic design with object-oriented programming. So when you're thinking about a problem and you're doing procedural programming, you usually think in terms of, okay, what kind of piece of data do I need? I'm going to ask the user for some data. What kind of calculations am I going to do? And then what kind of output I'm going to do. When you're doing object programming, what you do instead is you think of, okay, what kind of data do I need to do, and then what are the attributes of that data that I can bundle together. So you can decide upon a class, and then that class you can decide upon its instance variables. And then you write the methods that keep track of that data. Now, if you come from a strong procedural programming background, you've been doing C programming or COBOL for all your life, then the idea of doing this object-oriented programming can really bug you at the beginning. Now, that may not be the case for you. It's likely not the case, but I've had students who get to that point, where they come in from a procedural programming and they don't understand why they need to declare a variable in an entirely different file in a class, and then they need to add these function methods to that class in order to change it, when really just one line of code in their procedural program would have been able to create a variable and create it, right? Int salary equals 3, right? You just put that in your procedural program and boom, you're done. Why did I need to make an employee class that contained this salary instance variable and some getters and their setters for that? So honestly, and there's a video that I should show you where the person argues that people go crazy doing classes when they don't really need to, where it doesn't improve the program. And so if procedural programming is a reasonable enough solution for your problem, you don't need to take 3 times the amount of time to write everything in classes. The idea of writing classes is when you're working in larger projects and you need to be able to communicate these concepts with other programmers or to keep track of them yourself, the code is reaching a level of complexity that a simple procedural method, a main method, with 10, 50 lines in it, would not be able to manage well, to be easily maintained in the future, to be proven to be correct, or to be expanded upon in the future. So that's why you do object-oriented programming, is to make something that can be built upon in the future. You're building a structure that can be built upon in the future. Just like if you're going to build a shed, maybe going out and buying the wood and building your shed yourself, winging it, you're a good enough carpenter to do that, great. But if you're going to build a larger structure, you're going to build a house, or an apartment complex or whatever, you need to take great care in order to define everything beforehand and create your blueprints and, the specifications the builders need to follow and all that. It's kind of the difference between procedural programming and object-oriented programming. So top-down design for your methods. When you're writing the public method, if the method is fairly involved, you try to break it into subtasks. And then you have that public method called private helper methods. So, some people have like a rule of thumb that if a method is more than a page of code, well, I guess that depends upon your, your font size. But if your method is more than a page of code, you should try to break it down. You should break it down into subtasks, right? And so I guess, you could set some rule, that says, okay, if it's more than 30 lines of code or something like that, I'm going to try to break it down into subtasks. Because that one method is becoming complex enough to the point where conceptually it should be broken down into simpler, smaller steps so that those concepts could be more easily understood when you're passing the code to somebody else or when you're looking at it later, or you need to modify each individual step separately. So then you define those sub-steps, the helper methods, and then you finish writing your public methods before you start writing your private helper methods. Well, that's an odd thing to say. How can you write a public method if you haven't written your private helper methods? Well, that's an example of using what are known as stubs. Okay, stubs wasn't the very next slide, it should have been, but algorithmic design example. Implement the functionality of a square. The square should be able to set or assign its width, calculate and return its area, and draw itself with asterisks. Yeah, it's a neat idea. I should assign that to you, but I bet the code is right here. And so what is the attribute of a square? It's width. You provide a getter and a setter for it. Set width, get width. And you provide a draw method for the client. And what does the draw method do? It asks, do you want to print it with a border so it's got spaces in the middle of it, or do you want to print it solid so that it's filled with asterisks? And so this thing gets that information, and then uses it to draw it. And so, if it's supposed to be filled with a border, we call a draw border square. If it's supposed to be filled with solid, we call draw solid square. Now when you're first implementing this, you might make this do absolutely nothing. You might just make it print, you know, I am drawing a square with a border, right? All of these draw methods might just do that, right? They may not actually be accomplishing their task. You're just creating the structure that you're going to come in and fill in later. You get the code to a working state as soon as possible so that the main method, the client method, the driver method, you know, can be written to call it, you know, create an object of that class and call some of the methods, even if it's not accomplishing much left, so that as you go in and make changes to it, you're not breaking the code, you're enhancing its functionality. You're sure that it's continuing to hang together. And so what do they have here? Draw border square has got some subtasks. Draw a horizontal line, draw the sides, and draw another horizontal line. Well, draw horizontal line is the same regardless of whether it's drawing a bordered square or a solid square. So it was reasonable to break that into a subtask, right? And so a private helper method. Notice that this textbook says you don't have to do this dot in order to call a helper method. Well, that's true, you don't have to. But why not? I don't know why they're making a big deal about whether you're going to use this reference or not to access those, because that's always a choice, right? Any instance member of it, whether a variable or a method, you can choose whether you're going to use this keyword in order to access it or not. And they're saying, nah, it's a helper method, I'm not going to do that. Well, I would. And personal taste. And so draw sides is different for drawing something with a border than drawing something that is solid. If it's solid, you're not going to be drawing its sides, you're just going to be drawing horizontal lines over and over and over to fill it in. And so breaking that into its own task, its own helper method, was a good idea. And then on the next page there'll be some methods defined for doing that, right? A simple loop for printing out how many lines. Simple for loop for printing out how many asterisks are in that line. So here we go, here's a stub. After writing your entire program on pencil on paper, aren't you glad I don't make you do that? I had an instructor at one time that made you write out your entire program in paper before you entered it in a computer, and that's insane for a lengthy program, or whatever. Enter your program in a computer using stubs for your subtask methods. Right? I'm inside draw sides now. The benefit of using stubs. If the program is entered initially with stubs, the programmer will be to more easily get an initial successful compilation, which leads to a warm fuzzy feeling, which is incredibly useful, right? Okay, I'm being silly there. But if your code runs after 30 minutes of work, that's better than having to code for 2 hours before your code ever gets a first compilation and running, right? Build early, build often, get the code to a working state, even if it's not doing hardly anything, to where it can create the class, create an object of that class, and then call the methods that you expect the main code, the client code, to be able to do. So debugging is easier. After the program is successfully compiled and run with stubs, the programmer then replaces the stubs with the actual code, one method at a time. There's also a testing paradigm where you use tests. You create test functions, test methods, a framework of tests that tests every method in your class. I guess if they are private methods, then you could not test those individually. Ideally, after each method is replaced, it is thoroughly debugged. And if a bug appears, it should be easy to figure out. You knew it was working a moment ago. You knew it was working before the last change. Now that you've implemented the new helper, the subtask, then it's no longer working. You know where to fix it. So far, we've split each of our object-oriented programming into separate files. A file that describes the object, and then a driver file. It's legal to merge the two files into one, but we refrain from doing so. We'll continue to use separate files for most programs, but for a short program that doesn't do much other than illustrate a concept, we can merge the main method into the driven class. Honestly, I never do that. Why? It's a matter of convenience. There's one less file to create and there's slightly less code to enter. So what they're saying is that if you were going to use this circle class that we've got here, and you wanted to demonstrate it, you could conceivably make a main method inside it, public static void main. Excuse me, don't capitalize it, this is in C#. And it creates an example of itself. Circle me equals new circle, you know, and then me dot set radius 10, you know, and then double area is equal to me dot get area, assuming we've implemented a get area, right? And then print the area, do whatever. Okay, so now this class has both the main method and the pieces of data. Now normally, I won't maybe say normally, but we have said that if you're inside a method that is declared as static, the only other pieces of that class that it can access are other static methods. But we have decided that no, we don't want to make those methods status because we may want to be able to create a whole bunch of circles for our testing purposes. So we're going to make them instance members instead rather than class members. And so we actually have to create an object of our type before we can get a hold of that data. We can't just change radius right from here, right? I can't just call set radius right from here, you know, if I don't have an object, a reference to access it. So that is how you can create a class, a data class, and then you can embed a main method in it that uses the class, right? You just have to create an object of that type, of the same class. Circle me is equal to new circle, right? And then we can treat that as though we were inside. Well, I mean, now we have some client code, and this code did not need to be put into a separate file or a separate class, and that's true. I don't know why I resist that, but I do, but the textbook goes into it there. Why do it? It's a matter of convenience. There's one less file to create and there's slightly less code to enter. So for a while we've used the this reference to access instance variables from within a method. The formal explanation for when to do this. Use this with an instance method or constructor to access the calling object's instance variables. The this reference distinguishes instance variables from other things like local variables and parameters. That's why inside our setter we do this.radius equals radius, especially if the variable happens to have the same name. If there's a parameter or local variable with the same name as the instance variable, you have to use this. It's mandatory in order to distinguish them. However, if there is no ambiguity, you can omit the this prefix when accessing it. So if we were going to provide a getter for this, public int get radius, you don't have to use the this reference. You can just do return radius. Sure. But for the setter, public void set radius that accepts, you know, something. In this particular case, since we chose to make this parameter have the same name as that, using the this reference is mandatory. Now, you could get away with not using the this reference if you changed that variable name, right? If that was called Fred, then you could get rid of the this reference. Now that's a stupid example, but you could say, you know, I don't know, circle radius right there, and then you could set this radius is equal to circle radius. Why not just do this reference all the time? If you're using a smart editor like NetBeans or Eclipse, and you type in this dot and it pops up a list of all your members, that's really cool. It's really useful functionality. I don't see why to avoid using this reference. It doesn't take that much longer to type it. Okay, the idea of static members, class members. The math class. You do not have to create a math object before you start using its members. Right? So, excuse me, it's a capital M. So far I haven't had y'all type in any code whatsoever. I'm not even sure if it's necessary. So just fill out a video review form. You won't have anything to upload unless you've typed in this notepad stuff. But anyways, if we're inside main, right, public static void main, and yeah, I goofed that up. I did not put string square brace args there, so that code would not have compiled. You know, and same business here, string squares args. Okay, and you feel like using pi. You're going to calculate something's area. Double area is equal to, you know, pi r squared. So math.pi times whatever radius we're trying to figure out. But we want to square it, so math.pow, you know, 10 to the power of 2. Maybe we could have created a variable, you know, to hold the radius first. That'd be a little bit kinder, right? Eliminate this magic number from appearing right there. Okay. It would be dang annoying if we had to do and create an object in order to get a hold of pi and get something to the power of something. It's already annoying enough that Java doesn't have an exponent operator, right? So this would be annoying. Math equals new math, and then use, you know, lowercase, right? It would be annoying if you had to create an object of type math just to get a hold of these methods and these members like pi and POW and sine and cosine and tangent and, you know, everything else that the math class has. So these things are defined as class, as static members, so that you don't have to do that. Right? There's no reason, there's no information that needs to be maintained between two math calls, right? Because we always pass in the data necessary to calculate the tangent or the square root or the power of or anything like that. It doesn't keep any data between those calls, so that it has no instance data whatsoever. So the entire math class is constructed using static methods and static static variables like pi. That's a constant, right? So it's a constant static variable, and this would be a static method. So we would just get rid of that. And so what I want you to do is create your own class where every method is static, and we're going to call it mymath. Create a class named mymath where every method is static, a class method, i.e. class methods. And so what does mymath need to do? We're just going to add some silly functions to it that are not part of the primary math class, right? Goofball ones, like I'm going to write something that multiplies 3 numbers together. Add a method that will multiply 3 numbers together. And return the results. Add a method that will calculate the inverse of a number, which is just 1.0 divided by the parameter, right? And so, of course, your multiply method needs to have 3 parameters. So this method needs 3 parameters. So it needs to accept 3 arguments. And if it calculates the inverse of it, that's just 1 argument. This method needs 1 argument. And just to make it a little bit more interesting, we're going to do 2 methods. One that multiplies 3 numbers that are ints, and then, no, that's silly, just do it as doubles, and because ints would be, converted to doubles on the fly as needed when passed in as arguments. When the parameter variable received it, they would be doubles anyways. All right, I'm not coming up with any better ideas for what to add to our math class. Let's see if I actually have this as an assignment in the past that I'm going to crib from. No? All right. How about our fallbacks, right? Add a method that will calculate the area of a radius passed in as a parameter. So calculate and return. Done that often enough. And add a method that will that's enough. 3 methods will prove the point. They're all going to be static. And then your main method in another class, don't put it in the same one. Or I guess you could, since this chapter is about it. You feel like putting your main method inside? No, we can't. Yeah, we could. But don't. Put your main method in another class. Should use and display the results of each method of your My Math class. All right, that makes sense? Hope so. Alrighty, so that's enough homework. Doesn't really hit the idea of this particular chapter 8, but like I said, chapter 8 was pretty light on concepts. Encapsulate data, helper methods. Sure, maybe I should have assigned something where you had to use helper methods, but just tuck the idea of helper methods away into your brain and use the concept as you need it. I don't think we need to come up with some artificial structure in which to exercise that idea. All right, well, I'll see you next time.